Dear students, I welcome all for this session. In our previous session, we have discussed what is an arithmetic expression and what are the different types of arithmetic expression. So what are the different types? Infix expression, prefix expression, and postfix expression. And today we are going to learn one of the most important application of stack data structure, that is conversion of infix expression to postfix expression using stack. As mentioned in our previous session, the postfix expression is the most convenient form of representation of an arithmetic expression from computational point of view, because this postfix expression does not contain any parenthesis. Okay, so it is very necessary to learn how to convert a given infix expression to postfix expression. So here the main advantage of converting an infix expression to postfix expression is the position of an operator in the postfix expression itself defines the priority of that operator. So operator yav positional ide, so a position basis mele operation na carry out madutte computer. Okay, so the position of the operator itself decides the priority of that operator. Hence it is very necessary to learn the conversion of an infix expression to postfix expression. So before we learn this conversion, let us understand the procedure. Okay, so the procedure to convert an infix expression to postfix expression is as follows. First, the given infix expression is considered as an input expression. And now you are going to scan each symbol in the input expression one by one. Symbol in the sense it is an operand, operator, and special symbols like parenthesis, etc. Okay, so you are going to scan each symbol in the input expression. Input expression means it is an infix expression one by one. And now in the second step, you will check whether the scanned symbol is operand. If the scanned symbol is operand, you are going to output that operand directly on the screen. That means the computer is going to display this operand directly on the output window. Okay. If the symbol is opening parenthesis, if the symbol that is scanned is an opening parenthesis, then you are going to push this opening parenthesis onto the stack. Initially, the stack will be empty. And if the scanned symbol is a parenthesis, you are going to directly push this onto the top of the stack. Okay. If the symbol is an operator, if the symbol is not an operand, if the symbol is not a parenthesis, that is opening parenthesis, if it is an operator, then what you have to do? You have to do some checking. Okay, let us see what you have to do if the symbol is an operator. If the symbol is an operator, push the operator directly onto the stack if the stack is empty. If the stack does not contain any operator in it, then the stack is empty. So in that scenario, you are going to push that scanned operator directly onto the stack. If the stack already contains certain operators and the topmost element of the stack, if the topmost element of the stack is an opening parenthesis, if it is an opening parenthesis, then also you are going to push that operator, the scanned operator, directly onto the stack. In the other case, that is the else case, check the priority of the scanned operator with the priority of the topmost operator of the stack. If the stack already contains certain operators and the topmost element of the stack is not an opening parenthesis, then you have to check the priority of the topmost operator of the stack with the priority of the scanned operator. If the scanned operator has the highest priority, if the scanned operator has the highest priority, then you can directly push that operator onto the stack. Or else, if the scanned operator priority is not higher then the priority of the topmost operator of the stack. Then what you have to do, you have to pop the operator from the top of the stack and output it until the stack topmost operator priority is less than the scanned symbol priority. So you have to pop one operator at a time until you find a topmost element or the topmost operator whose priority is less than the scanned symbol priority. So after popping the operators from the stack, and then you will find an operator whose priority is smaller than the priority of the topmost element of the stack, then you can push that scanned operator onto the stack. So if it is an operator, you have to do certain checking. Okay, you have to check with the topmost element of the stack. And next, after pushing the operator onto the stack, next, if the scanned symbol is a closing parenthesis. See, given an infix expression, the infix expression can consist of operand, opening parenthesis, operators here only arithmetic operators, and a closing parenthesis. If it is a closing parenthesis, then what you have to do is, you should not push this closing parenthesis onto the stack. You have to pop all the operators. You have to pop all the operators from the stack and output them until an opening parenthesis is found. So until an opening parenthesis is found, all the operators from the top of the stack is popped, and it is placed on the output window. Okay, so this process is repeated for all the symbol. For every symbol that you are going to scan in the input expression, you have to repeat this process. You have to repeat the step 2 to 5 until all the symbols of the infix expression is scanned. So if there is no symbol in the infix expression, you have completely scanned all the symbols of an infix expression, then you should not stop there itself. Okay, so you have to check whether the stack is empty or not. If the stack is not empty, you have to pop all the operators and you have to place it on the output window. So here, what you are doing here is, you are just considering one stack for storing the operators. So you're going to store the operators in the stack based on its priority. So according to the priority of the operators, you are going to store it in the stack. And then you will pop all the operators from the stack and you're going to place it on the output screen. So on the output screen, at the end of all the 7 steps on the output screen, you will see a postfix expression of a given infix expression. So that means the converted representation of an infix expression. You are going to get the postfix notation of an infix expression at the end of the 7th step. Okay, after performing the 7th step, now the stack will be empty. So this is what the procedure that you have to follow to convert a given infix expression to postfix expression. Let us understand this procedure with an example. Here I've considered an infix expression A star B divided by opening parenthesis A minus C closing parenthesis plus D into E. So this is an input expression. This is a given infix expression. Now we have to convert this given infix expression to postfix expression. So what you have to do, you have to write 4 columns. You have to write 4 columns. The first column, name it as scanned symbol. The second column is named as action. And the third column is considered as stack. And the fourth column is considered as the output. So this output column at the last step, it will give you the postfix representation of this given infix notation. So after writing these 4 columns, next, what you have to do is, you have to consider initially the stack as empty. So initially the stack is empty. The stack does not contain any operator. And also the output window also does not contain any symbols. Now you are going to scan the first symbol. So which is the first symbol here? Which is the first symbol here? It is A. Okay. So when the scanned symbol is an operand, when the scanned symbol is operand, then you are going to directly output on the output side. Okay. So just output it. So on the output side, write the scanned symbol, which is an operand, that is A. Okay. Next, you are going to scan an operator. What operator it is? It is star operator. So when it is an operator, because the stack is initially empty, there are no operators in the stack, you are going to directly push that operator onto the stack. You are going to directly push that operator onto the stack. So that completes two symbols. The next symbol that is scanned is operand, that is B. Because it is an operand, you are going to directly output on the output side. So now output side contains two symbols A and B. Okay. Next symbol that is scanned is division operator. Division operator. So now to push this division operator onto the stack, you have to check the priority of the existing operator on the stack. So what is the priority of the existing operator? It is equal to the priority of the scanned symbol. In that scenario, you have to pop the existing operator from the top of the stack and you have to place it to the output side, and then you have to push the scanned operator onto the stack. So because of that, you are going to pop star from the stack and then you are going to output, and next you are going to push division operator onto the stack. Okay. Next, after this division operator, you are going to see the opening parenthesis. Because this is an opening parenthesis, what is the procedure? So the procedure tells you to push this opening parenthesis directly onto the stack. Without checking any condition, you are going to push this opening parenthesis onto the stack. Now, on the top of division operator, opening parenthesis is placed. Okay, the topmost element is now opening parenthesis. And the next operator that is scanned is the next symbol that is scanned is an operand A. Because it is an operand, you are going to directly output it. So the output side contains A, B, star, A. Next symbol that is scanned is minus, subtraction operator. And because the topmost element of this stack is an opening parenthesis, then what you have to do, without checking any condition, you have to push this minus operator onto the top. So after parenthesis, minus comes, and the next symbol that is going to be scanned is C. Okay, which is an operand. Because it is an operand, you are going to directly output this operand on the output side. Okay. Next symbol that is scanned is closing parenthesis. So we have seen in the previous slide, when the closing parenthesis comes, what you have to do? You have to pop all the operators from the stack one by one, and you have to place it to the output side until you find an opening parenthesis. And once you find an opening parenthesis, what you have to do? You have to pop that opening parenthesis from the stack, and then you have to just discard it. Okay, or just throw that opening parenthesis. And now the stack contains only one operator, that is division operator. And the next symbol that is scanned is plus operator. Okay, while now to place this plus operator onto the stack, you have to check the priority of an existing operator on the stack. So the existing operator on the stack is division operator. The priority of this division operator is greater than the priority of plus operator. In this case, you have to pop the division operator from the stack and you have to place it to the output side. And then you have to push plus operator onto the stack. After this operation, next symbol that is scanned in the input expression is D. So this is an operand you are going to directly output on the output side. Next, you're going to scan star operator. So because the star operator has got the higher priority than the priority of the topmost element of the stack, that is plus operator, you can directly push this star operator onto the top of this plus. Now the stack contains star operator as the topmost element. In the next step, you are going to see the last symbol, that is E. Because it is an operand, directly you are going to write it on the output side. And now all the symbols in the given input expression is scanned completely. Okay. Now the input expression does not contain any symbol. And now before ending the operation, you have to check whether the stack is empty or not. Here, the stack is not empty. It contains two operators, that is plus and star operator. Because the stack is not empty, you have to pop all the operators from the stack one by one, and then you have to place it to the output side. So after popping star operator and plus operator from the stack, now the stack becomes empty, and the output side contains the postfix notation of the given infix expression. This is the postfix expression of the given infix expression. So it is very clear. If you follow the procedure that was given in the previous slide, you will end up in getting the postfix representation of the given infix expression. So here you can see in this postfix representation, there are no parentheses included. So postfix representation and prefix representation is free from parentheses. Because of that reason, we prefer the postfix and prefix representation for evaluation of arithmetic expression in computer science. Okay. So this actually completes the conversion procedure for the given infix expression to postfix expression. So here are some of the assignment problems to convert the infix expression to postfix expression. So once you solve this assignment, you will be knowing how to convert the given infix expression to postfix expression. And this completes the today's session. I hope all of you will do this assignment so that you will be learning the procedure properly. Okay. Thank you.